So lesson 3.5 is systems of equations, but notice what's different. Instead of the 2 we're used to, there are 3. 3 equations means there are 3 variables. We're not just talking x and y, we're talking x, y, z. I do. Welcome. And so you can always undo the staple and just take that page if you just need that page. So.
Well, I don't know what my limit is.
Okay, so you might want all the pages is what you're saying. Okay, so 3 equations, 3 variables. Now, there are, if you look, on this page it says using elimination. On midway through the back page it says using substitution. Okay, similar to when we just did 2 equations, elimination, substitution. I'm breaking this up. We are not doing more than just elimination today. Because at this point, we're hitting brand new area. This is not something you did in Algebra 1 that I am just reviewing. This is taking our elimination method today and expanding it, learning how to apply it to this bigger scenario. Now, what do you notice also about the workspace on these problems? There's big. I'm just going to warn you ahead of time. Yes, I'm going to fill that space. Okay? The more organized you can be on this problem, the better. Okay? You've got to be very organized, and you've got to be very careful with your math, right? Because, like any problem, one small negative loss or multiplication, 2 times 3 is 5, one small thing like that has a domino effect, right? It affects everything. So, you need to be very careful. I'm going to take you through a process. I think you'll have a good idea of how to do this. I'm also going to tell you there are 4 homework problems tonight. Because these are time consuming, right? Once you learn the process, you can go quicker on your own than I can, I can solve this quicker on my own than I can leading a class through it. But, there's going to be some practice here. Okay, so, as we look at example 1, are you ready to try it? Yeah. Okay, organization, guys. I cannot stress that enough. As we look at this, elimination. You remember which one eliminate is, right? We set it up so that we can eliminate one of the variables. As you look at these 3 equations, which variable are we set up best to eliminate, would you guess, based on what you know about elimination right now? I wouldn't say either of those. Why would I say Z? Why are we best set up to eliminate Z's? Ignoring signs, the key to me is that it's 1Z, 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 yes? So they all have the same numbers. Now, sign-wise, you might have to finagle with, but we all have the same numbers. So my recommendation, less multiplication involved, we are set up to eliminate the Z's. So this first problem I take you through, we are going to eliminate the Z's. You always want to start by picking, okay, what variable do I need to eliminate? Now, the other thing you always want to do, or until you get the hang of it, I'm going to number my equations. Number them, label them something so that you can find where they're at in your paper. I'm going to number these equations, equation 1, equation 2, and equation 3. And if nothing else, that just helps me to keep you guys all with me. So you're not saying, wait, which equation did you grab? What did you do here? Okay, yes. Of course. Yes, it's probably a good day. Well, I guess it doesn't have to be pencil. I like pencil, but. Okay, so if we eliminate Z's, which 2 equations should we pick to do our first elimination? 1 and 2 are good. Why are 1 and 2 good to eliminate Z's? They're already opposite signs, right? Signs. A plus 1Z, a minus 1Z. So I'm going to come over here, and I'm going to put 1 and 2 together on top of each other. So 1, I'm going to rewrite as 2x minus y plus z equals 4. I'm going to put 2 directly underneath it. X plus 3y minus z equals 11. Since I'm already set to multiply, okay, or since I'm already set to eliminate, I don't need to multiply, right? Because I've already got plus z and minus z. Since these are opposite signs, realize what are we doing with our equations? We're going to add them, right? 2x plus 3x, or excuse me, 2x plus x. 3x. You know where my brain was going, don't you? Negative y plus 3y.
2y. 2.
Plus 2y. Z plus negative z. It's gone. Carry your equal sign down. 4 plus 11.
15.
15. Okay, we have just created a new equation.
Yes, we did.
I'm going to call this equation 4. Okay? Again, I want to be able to refer to it by something when I come back to it later. So I'm going to call my 3x plus 2y equals 15 equation 4. Now, repeat this process to come up with an equation 5 using a different pair of equations from up top. Does that make sense? So, this is my divider that I'm going to do. So earlier, I used 1 and 2. Now I have to use basically something involving 3, right? You can use 1 and 3. You can use 2 and 3. Which would be the better pair set up? 1 and 3? Why would 1 and 3 be good? Wait, I'm still, okay, wait, back up. I need to clarify. We're still eliminating z's.
Yeah.
Let me clarify. I obviously forgot, I did not say that obviously based on the response of what I was getting. Okay, so we're going to repeat the process in that we're going to take a different pair of equations. We're going to eliminate z's again. It is important that you eliminate the same variable again for this process to flow when we get to the next part. Okay, so hang with me on it. So, which two equations would be good if we're eliminating z's again? 1 and 3. Because it's a plus z and a minus z, correct?
Yep.
Okay, so I'm going to write these down. I'm going to write down 1, which is 2x minus y plus z equals 4. And I'm going to write down 3, which is 4x plus y minus z equals 14. Again, my z's are plus z minus z, right? So opposite signs, so my equations are set up to add. 2x plus 4x. 6x. Negative y plus y. 0. Okay. That didn't have to happen. It just happened. Okay? It actually is going to make life nicer for us. Z plus negative z. That's also cancels. Carry down my equal sign. 4 plus 14. 18. I'm going to call this equation 5. Now, as I said, life just got a lot easier with this problem.
It did, actually.
Okay? And I'm hoping maybe you guys can see where you can go next. My normal thing would be now we would take 4 and 5 and put them together to eliminate a variable. That would be because normally 4 has x and y, and in a normal situation 5 would have x and y. We'd put those together and eliminate a variable. But what do you see right here?
You can divide that.
Can we use 5 and finish that part up?
Yeah.
If my equation 5 is 6x equals 18, Caden said divide that, so I assume he means divide by 6, and what is x? 3. Okay, we have found 1/3 of our answer. Thoughts on how we can use that x equals 3 to find another answer? Jacob? Into equation 4. Okay? You know that equation 4 that we had?
Yep.
Let me write out equation 4. 3x plus 2y equals 15. You see why I number these equations now, don't I? Yes. So we can refer to them, and so that you can keep track of where they are on your paper. Equation 4 is 3x plus 2y equals 15, and what do we know? X equals 3.
The 3 and the x.
So, 3 times 3 plus 2y equals 15. 3 times 3 is 9. If it's 9 plus 2y equals 15, what are we doing?
Subtract 9.
Okay. Subtract the 9 over. 2y equals 6. And y is 3, because you can divide by 2. Okay? I would say that I'm 2/3 of the way done with this problem. I know x, I know y. Okay, in order to find z, he says plug it into equation 1. Does that work? What are your options? You can plug x and y into equation 1, 2, or 3. We don't all have to do the same thing. You pick whichever one looks better to you, you know? Less negative, smaller numbers, whichever one looks more comfortable. So, he said equation 1 works for me. Equation 1, if I write this out, is 2x minus y plus z equals 4. So I'm going to plug x equals 3 in there, and y equals 3 in there. So 2 times 3 minus 3 plus z equals 4. And you can't see a thing I just wrote. My apologies. Now, if you've ever wondered why I put a slash through my z's, do you see why? Because in a big problem like this with so much going on, it can so easily become a 2. So that would be why I put the mark through my z's. Okay, 2 times 3 is 6 minus 3 plus z equals 4. 6 minus 3? 3 plus z equals 4. And subtract 3. And z is 1. Did anyone try a different equation and get the right answer? Or did everyone just want to be the same on this one?
I felt like I was just doing the same.
Okay. Now, to express your answers, what were you doing on the quiz yesterday to express your answers? Ordered pairs. Now we're going to express them as an ordered triple. Okay? Makes sense? It's called an ordered triple. An ordered pair goes in the order XY. An ordered triple goes in the order XYZ. So this answer is 3, 3, 1. Yes. If here's your x-axis, here's your y-axis, the z-axis is going.
Coming at you.
Yeah.
So it's like a 3.
Yep.
Yeah.
It's very hard to just graph on paper, so.
It's kind of easy.
It's doable. It is doable. It looks overwhelming. And if you were to just look at this problem without me talking you through it, it probably would be overwhelming. But I think if you follow the process, you'll do okay. Just, it does take some time, which is why you only have 4 homework problems. And you have to not make careless mistakes. I hate to tell you, but the careless mistakes will be the downfall. Okay? Oops. Okay. So, start looking ahead. My plan is to do this front page today. That's my plan. So, if we can get this front page done, we'll have done several varieties. Okay. Are you starting to look at example 2?
Yeah.
Okay. 3 equations. What am I going to do with those 3 equations?
Well, we're probably going to do the same thing as I did at the top. But it's exactly the same.
Okay. At some point, at least while you're in the learning process, I would encourage you to keep them numbered. Someone from my pre-cal historian reminded me that he didn't like my numbering system, so he used like ABC because he liked that. So you come up with yours. You just have to, figure out what you want to do. Okay? So, after you get them numbered, we need to pick, and this time it's as a class, it would normally be on your own, which variable would we like to try eliminating this time? Do we understand why, as a whole, we're going to eliminate y's as our first variable?
Yeah.
Because it involves no multiplying, right?
Yeah.
So, I'm just going to
Eliminate y.
That means, in my first 2 steps, I'm eliminating y's. Pick 2 equations that you want to put together to eliminate y's. 1 and 2?
Yeah.
Yes. You can, it wouldn't necessarily have to be y's. Is that what you're asking? Yeah, not everyone would necessarily pick the same variable to start eliminating. Okay? On this one, the reason I see y's is because they're all 1 y's. So I don't have to multiply anybody by anything. Okay? But if those y's weren't all the same, but yeah, not everyone has to do the same thing. Okay, so if we pick y's, which equations should you guys start working with? 1 and 2?
Yeah. I agree.
So 1, and guys, here's another, besides careless mistakes, be very careful to copy your equation over correctly. And neat handwriting matters, because if you leave off a negative, it gets ugly real quick. So there's equation 1, equation 2, x plus y plus 3z equals negative 3. We're eliminating y's, and if I eliminate y's, they already have opposite signs, which is probably why you guys picked equation 1 and 2, correct?
Yeah.
Okay. X plus x. 2x. Negative y plus y. Cancels. Z plus 3z. So plus 4z. Carry down your equal sign. Negative 1 plus negative 3. Negative 4. And what am I going to call this? I'm calling this equation 4. And you will notice I always circle my equation numbers so it doesn't look like part of the equation. That's my reasoning. Again, some of you are very organized people and you will come up with your own process.
I kind of like using the letters, actually.
And I can see the valid point in it, as long as you're not using the letters as a problem.
Yes.
I can see that.
You should definitely make it X, Y, Z. That's how we should label it.
That would be all one.
Okay, so, now, do we understand what comes next this time?
Yeah.
We used equation 1 and 2 to eliminate y's. Now what? Use 2 and 3 because what are we eliminating again? Y's. It is incredibly important you eliminate the same variable 2 times in a row. This time, 2 and 3 because it's a plus y minus y. I can go with that. So let's write out 2 and 3. 2 is x plus y plus 3z equals negative 3. 3's 2x minus y plus 2z equals 0. Again, my y's are plus y minus y, so I'm going to add x plus 2x, y plus negative y, cancels, 3z plus 2z, carry down my equal sign, negative 3 plus 0, negative 3. So my equation just became 3x plus 5z equals negative 3, and I am calling this equation 5. Okay. This problem is going to work out a little more typical. That last problem was not necessarily your typical problem, but it was, kind of eased us in. So now your job is to put equations 4 and 5 together and then examine where we need to go. So I'm going to bring them over here. And I'm going to write equation 4, which is 2x plus 4z equals negative 4. And I'm going to put equation 5 right below it, which is 3x plus 5z equals negative 3. So right there, the whole reason I eliminated y's twice is because now I've gotten down to 2 equations with 2 variables. So right here, you're doing what you just did on the quiz yesterday. Okay? You're doing what you just did on the quiz yesterday. 2 equations, 2 variables. What do you want to eliminate? Okay? If we eliminate x's, what is our goal? We get our x's to become 6 x's. If you really want to, you can eliminate z's and make them 20 z's, right? Your call. So if I eliminate x's, what am I multiplying the top equation by? 3. What am I multiplying the bottom equation by?
2.
And one of these, let's multiply by a negative. I'm going to go with the bottom one multiplied by negative 2. After this point, I do not renumber that. I do not number any more equations.
You can say 4.5.
I mean, I just from here do the math. I never really go past equations 4 and 5 in terms of numbering. We'll get y at the end. We got rid of y so that we can actually do something with these. Okay, so multiplying by 3. This top equation becomes 6x plus 12z equals negative 12. That is my modified equation 4, if you will. Again, as I said, I don't really number it, but that's what it is. And I'm going to do the same thing. Let's modify equation 5. Multiply by negative 2, it becomes negative 6x minus 10z equals positive 6. So again, if you want to call those like equations 6 and 7, that's fine. I don't. Because from here, you just kind of follow the flow. 6x and negative 6x are opposite signs, so I am set to add these equations together. What is 6x plus negative 6x? They cancel. 12z plus negative 10z. 2z. Carry down my equal sign. Negative 12 plus 6. Negative 6. If 2z equals negative 6,
Z is negative 3.
divide by 2, and z is negative 3. Once I can get an answer, I'm headed towards the end. I'm not going to create any new equations at this point. It's just a matter of using these pieces to find an answer. Okay, so just kind of drawing a line here to help separate things. What do you think I should do with that z, the fact that z equals negative 3?
Probably plug it in.
plug it in where?
So anything you want.
Plug it into
4 or 5. I can't go back to 1, 2, or 3 because I only know z. I need to find an equation that has z and at most one other variable. So you can use, and I would use the original 4 or the original 5, whichever one makes you happier. Right? I don't know how else to explain it other than that, but okay. 4 or 5. There's not a whole lot of difference between them. So if I write down equation 4, it's 2x plus 4z equals negative 4. And I'm going to put z into that, correct? So 2x plus 4 times negative 3 equals negative 4. Yes? Because I only know z, and I would still have x and y in my original equations 1, 2, 3. So I'd have more work to do, whereas this way I'm going to be able to find my next variable. Okay? So 2x, 4 times negative 3 is minus 12 equals negative 4. If it's 2x minus 12, add 12. 2x equals 8. And if 2x equals 8, then x equals 4. I know z. I know x. Have some of you finished this problem without me at this point? What do I do to find y? We're going back to equation 1, 2, or 3. Your pick. So if we use equation 1, I'm going to write it down the fact that it's x minus y plus z equals negative 1. So I'm going to have 4 minus y plus z, so that's minus 3, equals negative 1. Like terms, I have a 4 minus 3. 4 minus 3 is 1. So I have negative y plus 1 equals negative 1. If it's negative y plus 1, I should subtract 1. Negative y equals negative 2. If negative y equals negative 2, switch the sign, divide by a negative, multiply by a negative. How does your brain work? So if we divide by a negative, it now becomes y equals 2. Okay. Realize there are lots of different directions you could have gone along this path, aren't there? We're not all going to do them the same. What is my final answer?
2, negative 3.
2.
Okay. You can't see what I wrote, but I wrote 4, 2, negative 3. Okay, guys. That's the gist of it. I do want to do one more because there's try and do one more. I'm running out of time, aren't I? Being too casual here. Okay. One last problem. And there, I at least need to get through the beginning part to give you an idea because it's something we haven't run into yet. Do you want to eliminate x's, y's, or z's on this next problem? I hear x's, which is kind of my plan of where I wanted to go. Okay. If someone else said they wanted to go y's, that would be a good direction to go as well. Z's would work. But I'm going to go with, we're going to at least get started with x's.
Yeah, we haven't got rid of those yet.
That was my other reasoning for doing it, just to prove that you can use any variable you want. Okay, we're going to eliminate x's. Where's the easy one to start with? 1 and 3, because 1 and 3 are x and negative x, correct? So 1 is x plus y plus 2z equals 3. 3 is negative x minus 2y plus z equals 10. My x's are positive x and negative x, so opposite signs, I can add them. Yes. X plus negative x. Okay, that's 0. Y plus negative 2y. Negative y. 2z plus z plus 3z equals, carry down that equals, 3 plus 10. 13. I'm going to call this equation 4. Okay, we have to use a different pair other than 1 and 3. So we have to use 2 with something. We can use 1 and 2, or we can use 2 and 3. Honestly, they both can work. I personally would pick 2 and 3 because even though they don't have the same number, they have opposite signs. And remember, what variable am I eliminating again, the second time in a row? X. Don't change the variables you're eliminating. So I'm going to write down 2 and 3. And we're going to have to talk about what has to happen. So 2x plus y plus 3z equals 7. And negative x minus 2y plus z equals 10. As is, can I eliminate my x's? No. What do I have to do here to make these the same? Multiply equation 3 by 2. What about the top equation? Okay, multiply by 1, but it stays the same, yes? So now I'm going to rewrite my new equation. I'm not going to number them, but they're just going to be my new equation. So equation 2 stays as is. 2x plus y plus 3z equals 7. Equation 3 becomes negative 2x minus 4y plus 2z equals 20. This is my modified equations 2 and 3. 2x and negative 2x are opposite signs, so I can add them. 2x plus negative 2x.
No x.
0x. Y plus negative 4y. Negative 3y. 3z plus 2z. 5z. Carry down the equal sign. 7 plus 20. 27. This is equation 5. Okay. What do I do with equation 5? Put it together with 4. So I'm going to write them on top of each other. 4 is negative y plus 3z equals 13. Equation 5 is negative 3y plus 5z equals 27. Now we're back to doing what you did on the quiz. 2 equations, 2 variables. Do you want to eliminate y or z? I would agree, probably say y. If this denominator is already negative 3y, multiply the top by a negative 3 to then turn around and make that positive 3y. Yes? Okay, carry over. Equation 4, when I multiply it by negative 3, becomes 3y minus 9z, oh no, equals negative 39. Equation 5, I'm going to carry over as is, negative 3y plus 5z equals 27. And my 3y's have opposite signs, so we're going to add 3y plus negative 3y. Cancels. Negative 9z plus 5z, negative 4z. Negative 39 plus 27. Negative 12. If negative 4z equals negative 12, divide by negative 4, and z is 3. What do I do with z is 3? I like to plug it into equation 4 or 5. Your pick. So if I plug it into equation 4, 4 is negative y plus 3z equals 13. So negative y plus 3 times 3 equals 13. I'm off the screen, sorry. Negative y plus 9 equals 13. Subtract 9. Negative y equals 4. Divide by negative 1, and y is negative 4. You finish it up the same way with z, and I'm going to finish that. I will tell you z is, not z, we already have z. X. X is going to be 1. For tomorrow, guys, practice these. I should see, bring in some work. Don't come to me and say, I don't know what to do. Bring me some work. I'll help you find your mistakes. I'm just going to use equation 1 here for anyone that cares. X plus 2y, excuse me, dang it. I'm trying to be quick, and it's not working. So x plus y plus 2z equals 3. So x I don't know, plus y is negative 4, plus 2 times 3 equals 3. So x minus 4 plus 6 equals 3. Like terms, minus 4 plus 6 becomes x plus 2 equals 3. Subtract 2, and x is 1. Final ordered triple is going to be 1, negative 4, and 3.
Are we going to do like the X, Y, and Z ones?
Hold on a second.